Hello friends, so this is the sixth question related to diode connections which we are going to discuss. So here we have again a silicon diode, most popular diode which is used. It is connected to a AC voltage source and it has been given that the peak value, maximum value is 25 volt, only that. And it is connected across a 600 ohm kind of a load resistance. And also it has been mentioned that the forward resistance, the diode resistance, is 15 ohm, and it has been asked to find the peak value of the current flowing through the diode and the peak value of the output voltage. Okay, peak values, maximum values. And again there is another question, is find the current when the diode is assumed to be ideal. Ideal means no built-in potential, 0 volt built-in potential. Okay, so again we will cover the first portion first, then we'll go to the second one. So the first important thing to find out is whether this diode is on or not at the peak value 25 volt, because everything is related to the peak value. So we will consider only the peak values, because the peak value of current will occur at the peak value of the AC voltage. Same thing as the output voltage. When the current will be maximum, the output voltage, the voltage drop across the 600 ohm resistor will also be maximum. So everything is related to this 25 volt. So we will go the second method which I always use, that is replacing the diode with its equivalent circuit, built-in potential and forward resistance. Then we will connect the peak value. We will consider, use the peak value 25 volt, let's say, and we will connect the 600 ohm resistor. Okay, this is 15 ohm, 600 ohm, this is 0.7 volt. So now this current I, it will be, let's say, IP, peak value, the current, because it is maximum. So if we put KVL here in this loop, we will get 25 minus 0.7 because the built-in potential, the barrier potential for silicon diode is 0.7 volt. For germanium it is 0.3. Here it has been given silicon, so it is 0.7 volt. Okay, minus 15 IP minus 600 IP is equal to 0. That implies IP is equal to 25 minus 0.7, 615. It is an ohm, so it will be ampere. So it is coming, let's say, calculate, it's 24.3 by 615, it is coming around 0.0395 ampere, which is, we can also write as 39.5 milliampere. Now the important thing here is that it is positive direction. What it means is that this current is flowing like this, IP, or this is like this, from P to N the current is flowing, okay, from P to N. So when current flows from P to N through the diode, it means that the diode is on, it's forward biased. So as the diode is forward biased, everything that we did with the circuit, it is true. Okay, it will be intact, all the results are true. It means that the peak value of the current is this 0.0395 ampere or 39.5 milliampere. So the next thing is to find the peak value of the output voltage. So V0P will be simply peak value of current into 600 ohm, which is 0.0395 into 600. The result is coming around 23.7 volt. 23.7 volt it is coming. So the peak value of the voltage is 23.7 volt. This is 39.5 milliampere or 0.0395 ampere. So these two results we got: the peak value of the current, peak value of the output voltage for the diode having a built-in potential of 0.7 volt, forward resistance of 15 ohm. Next is to find the current when the diode is considered to be ideal. So a diode is ideal, it is considered to be ideal when it has no forward resistance, no built-in potential. Okay, I have already discussed about the various representations of diode, okay, various circuit models. Please check out those videos. So in the ideal case, the diode, it has no built-in potential, this is 0 volt, and resistance is also 0 ohm. It means there is no such thing. Okay, it can be simply replaced by a short circuit. Okay, it can be replaced by a short circuit. So in that case, it will be simply 25 volt and 600 ohm. So in that case, V0 will be equal to, the peak value will be 25 volt, and this current will be 25 volt by 600 ohm, which is coming around, let's say, it is coming around 0.04167 as ampere, which is, it is 41.6 milliampere. Okay, so this is the result for the diode in the ideal case, okay, when the diode is considered to be ideal. So this is the sixth question that we have discussed related to diode connections. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.